6.5, we kind of want to undo the first part of what we did in the 6.4 notes. Where if you think back to the notes from 6.4, we had a parabola that was in vertex form. We wanted to convert it to standard form. So we'd FOIL and then kind of finagle things. We end up getting y equals blah, 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 blah. Here we need to try to do that same thing but backwards. So if you have a parabola in standard form, sometimes it's nice to have it in vertex form so that you can easily figure out what the vertex of the parabola is. Say you're looking for the highest point of a ball that's thrown, convert it to vertex form, Shazam. You have your y value, which would be the highest height. You have your x value, which would be the time that it reached that height. Unfortunately, there's a few more steps to it going this direction. Exactly what completing the square is in an effort to keep the notes short, I'm not going to go into that, but check it out in your book. It's really pretty cool. This first part here, the 6.5, is all going to be stuff that is really just the skills you need to be able to do the steps. I probably would just kind of watch and not take any notes on it and then see how it goes from there. I did pass out in class, hopefully, a sheet that has some steps on it. Otherwise, you'll want to copy them down as you look at the notes. But this first part, I want to start out with just a reminder that we went back, and way back at the beginning, we had our binomial square theorem. So it said if you have x plus y quantity squared or x minus y quantity squared, you're really going to get pretty much the exact same answer that you have when you FOIL those, because you can't just say x squared plus y squared. X squared would be the first, and then when you have your outside and your inside, it's going to end up being a plus 2xy. So that's the outside and inside combined. And then your last terms would be plus y squared. Same exact thing down below when we just change the minus sign in the middle of our binomial. So you're going to have a minus 2xy. And that's kind of going to be one step in there that we're going to have to try to take this and work backwards into one of these binomials. So my first example then, I'm going to say I have this empty binomial, we need to fill it in, equals x squared plus 6x plus 9. And, well, because we start out with an x squared, we know we have to start out with an x. The sign in the middle, the only difference between these two up here is that if it's a minus in the middle, you get a minus here. If it's a plus in the middle, you get a plus there. So we look at this sign right here, and that tells us it's going to have to be x plus some number. And now you can find y one of two ways. Y, the number here after our plus, is either going to be square root of 9, because this end part is y squared is 9, so that would tell us it has to be 3. The other way to get it is that this here we have a 2xy. If you take the x out of it, we're left with 2y. Take the x out of it, you're left with 6. So you really have that 2y has to be 6, which then would say y has to be 3. Same as there. So you kind of pick whichever way you want to do it. I kind of look at it like you have this first part of the equation, and you get rid of the 2 here in the x squared, leaves you with an x. You have the plus, and you divide by 2 here to get the 3. But anywho, let's do a couple more of those kind of rapid fire. So we have some binomial squared is going to be x squared plus 4x plus 4. And then I'm going to pause a second. I'm hoping that you're writing it in. But because we have an x squared, it's going to be x. Because there's a plus right there, it's a plus. Then half of the 4 gives me a 2. Or you could say square root of the 4 over here, and you still get a 2. So next example. And please, please, please work ahead. I'll pause for a second, and then we can see if you came up with the same answer. So now I have some binomial squared equals x squared minus 10x plus 25. And the x squared here tells us it's going to be an x in the front. There's a minus in front of our x to the first term, so it'll be minus. And half of 10 is 5, or square root of 25 gives you 5. Then next one like this, kind of the last one like this, I have some binomial squared equals x squared plus 8x. And here we run into a problem. Because if you were to take, well, maybe I should go through it first. So what's it going to be in front? We'd have an x. The sign has to be a plus because of our plus right there. It's going to be a 4. Now we get to the problem. If you'd taken FOIL this x plus 4 quantity squared, you wouldn't get x squared plus 8x. Every time we FOIL a binomial, or FOIL two binomials, you always end up with a perfect square trinomial. There has to be some number here in order to get it to work. And what that number would be is it'd be 4 squared. So if you take this and compare it with our first part up here, the missing term, maybe I'll circle those in black, this here, and compare it to our binomial square theorem with the plus in the middle. Well, this here, the missing part's going to be a plus y squared, so we'd have a plus. And my y is just 4, so plus 16. That's kind of the second set of steps, skills that you need to be able to do in this completing the square, converting from standard back to vertex. So you have to be able to figure out what's missing. So I'll just do a couple of those real quick. And so if we had an x squared plus 10x, to get this thing on the end, I'm going to say our format is ax squared plus bx plus c. What we're really looking for is we're looking for c. So I'm going to say c equals, well, if I take and kind of look at it like I have this binomial that's missing, we'll see if I can squeeze it all in. We're going to have an x, we're going to have a plus, we're going to have a 5. So you could kind of look at it as though half of this 10 gets you to the 5. So I'm going to say half of 10, that's going to be 1/2 of b, because that tells us the 5. And then this 5 squared gives us what c is going to be. So to find c, it's really half of b, half of the number in front of x to the first, and then you square it. So in this case, we'd have to add a 25 to the end. If we have a different one, x squared plus 30x, and then it's always plus here at the end. So what number are we adding? Well, you do half of 30 is 15, square it. You have to add 225. And then we'd be able to work backwards and say that's going to equal x plus 15, quantity squared. All right, another one, x squared plus 2x. This one seems a little bit weird, but you do the same exact steps to find c, find what we're adding there. It's going to be half of b, so half of 2 is 1. Square it, you get a 1. So this is going to be the situation where b is actually larger than c, which is going to be different than all the others. And then that binomial would be x plus 1 quantity squared. If we had a x squared minus 6x, it's still going to be plus. We're always adding some number here at the end. Half of the minus 6 is a minus 3. Negative 3 times itself is a positive 9. So x squared minus 6x plus 9. One more, and then we'll be done. So if we have a x squared minus 7x, unfortunately this one doesn't work out quite as nicely, and I can't do that in my head, but it's the same steps to figure out what you're adding. We do half of 7, so it's going to be 3.5. Take our trusty calculators, and do 3.5 squared. We're adding 12 1/4, so plus 12.25 there. And now we'd be able to go through and figure out that this has to be x minus. You could either square root the 12.25 or just cut the 7 in half. So x minus 3.5 quantity squared. Those really are the steps that you need for this second video, which is actually going to be the steps to go through and convert from standard form to vertex form. Have fun with the second part.